Okay, so we're moving on to logarithms. Logarithm functions from the exponential functions we just did, okay? So let's take the classic simple exponential function, y equals 2 to the x, okay? Here's its graph, just very roughly drawn, okay? Now, if we replace the y with the x and swap these two around, okay, to get the inverse, we're going to graph x equals 2 to the y to show you what the inverse graph looks like, okay? So again, if you want to have a look at these, plot a table, put some points in, this is what we get. Okay, here it is. Here is x equals 2 to the y. So here's a good visual over here. Remember, this was the original exponential function. Y equals 2 to the x. This is now the inverse, x equals 2 to the y. So notice it's actually been reflected across the y equals x line. Okay, a reflection across the y equals x line is the inverse. Little other points to just notice. Now notice the inverse. Okay, look at this. It crosses at 1, 0. Where the original exponential always crosses at 0, 1. Remember, anything to the power 0 is 1. So again, it's just showing the reflection across the y equals x line. Let's keep going. Now what the inverse actually is logs. So the exponential, the inverse is the logarithmic function. So again, look at here. If I look at this, okay, y equals 2 to the x equals 2 to the y, the exact same image here. We're going to call x equals 2 to the y, log to base 2 of x. This is the inverse. Right. Now again, look up here. 2 is the base and x is the exponent. Well, in logs, the 2 is the base here. This is log to base 2 of x. Read here. Log to base 2 of x. This means the power to which we raise 2 to get x. Now, not clear 100% right there, but great with examples, okay? Have a look down here. So if I actually put some values of x in, so if I want to kind of plot log to base 2 of x, what I'm saying is 2 to the power what will give me 8. Alright, so log to base 2 of 8 is 2 to the power what will give me 8. Well, can you see it's 3? Because here it is. 2 to the power 3 is 8. 2 cubed is 8. Okay, so log to base 2 of 8 equals 3. Now it's great to be able to check with your calculator, because have a look at this. If you were to put log to base 10 of 100 into your calculator, log to base 10 is just the log button on your calculator. We sometimes just write log to base 10 as log. That's the classic log. Remember, that's base 10. Okay. Now here we go. It's because 10 to the power 2 equals 100. Well, we know that 10 squared is 100. So log to base 10 of 100 must be 2. Okay. Now look at the visuals on this. Very visual. 2 to the power 3 will give me 8. So notice I went from here to here to here. Either side of the equal sign. Okay. Okay. 2 to the power 3 will give me 8. 10 to the power 2 will give me 100. So that's me going from logs to exponentials. If I go from exponential to logs, then I have to write the word log in, but it's still you going from this number to this number to this number. Okay, look. Log to base 2 of 8 equals 3. Log to base 10 of 100 equals 2. So just watch that black arrow, okay? It's like back and forth. So you've got to kind of get used to that, because when you change from one form to the other, you have to understand where those numbers go, okay? And final slide. This is just the generalization of everything, okay? So have a look at this. Y equals log to base a of x. Okay, we can say it's the inverse. Now, okay, here we go. So here's a standard base a. All right, well, can you see? This is where the base a is in the log. Again, reflection across the y equals x line. So this is when we have something like 2 to the x, 3 to the x, something bigger than 1, okay? Now remember, when we have fractions, something between 0 and 1, it looked like this. Maybe go back and look at your exponentials. That's a fraction like a half or a third or 2/3 to the power x. Well, okay, if that's the base, then of course this will be the base here, 1/3 or 1/2 or 2/3, okay? So that's just a generalization of everything I've just talked about.